Hello, welcome to CPSC 2070, Discrete Structures for Computing. My name is Larry Hodges, and I'll be the instructor for this course. Now that your first assignment is to read the syllabus, which is available on Canvas. So what is this course about? Discrete mathematics is the branch of mathematics dealing with objects that can assume only distinct, separated values. That means we're not going to be talking about fractions. You can think of discrete mathematics as anything that you can put in a one-to-one correspondence with the integers. So there's a first one, a second one, a third one, a fourth one. We might have an infinite number of objects, but we know, say, between the third and the fourth one, there's not another one that can pop up, like the real numbers, where between 1 and 2, there's an infinite number of fractions. We'll have things that are what we say are countable. Now, one of the themes of this course will be how do we determine if something is true? And if we think about it philosophically for just a few moments, there are lots of definitions of what truth is that you encounter in different disciplines. We can talk about legal truth, i.e. it's in the law, and so this is what can be done and what cannot be done. Authority. My mother said this is true, so it must be true. We have several variations of revealed truth. The holy book of any of the major Western religions we think of as revealed truth about what's true about the world and the universe. Also, many of us have this inner conviction of truth. I know in my heart that this is true. So you know in your heart that you'll make an A in this course. You may or may not be correct with your inner conviction truth. And things that have to do with the scientific method. We observe things and look at examples and we draw conclusions. If I drop a rock on the face of the earth, it falls at a certain speed every time I drop it because gravity is constant at that place on the earth. In this course, when we talk about truth, we're talking about formal methods of proof. We have axioms, things that we assume that are true to begin with, and the axioms could have come from any of these sources that we've talked about. Right from there, we have propositions, which are statements that may be true or false. We have theorems about the truthfulness of those propositions. And we have rules of inference that if we start with something that's true, how to make a further statement that's also true. And we have to be very careful when we do this because our intuition is often wrong. And the world is full of unfounded propositions, actually statements that are claimed to be true but are not true. And if you just do a random search on the internet, you can find lots of examples of different claims of truth that turned out to be proven wrong. Kellogg's Rice Krispies used to advertise that they help support your child's immunity. But it turns out that they were no more helpful than any other cereal, so they couldn't keep doing that. Pennzoil used to advertise that their oil was better at protecting cars than castor oil. Turns out there was no proof of that, so they had to quit doing it. And my favorite is that some of the so-called natural cereals contain the same ingredients as prescription drugs and federally classified hazardous substances. So natural, what's natural mean? Natural is something that you can get or find on the face of the earth, underneath the earth, or above the earth. There's nothing good or bad about it. So what is a proposition? Formally, a proposition is just a statement that's either true or false. So 4 plus 3 equals 7, given the base 10 number system, is a true statement. If we look at a more complex statement, such as for non-negative integers n squared plus n plus 41 is a prime number, is that true or false? Well, it's hard to look at it and say for sure. And it's also important to realize that when we say something is true mathematically, we mean it's true every time. If there's one counterexample where it's false, then by definition the proposition is not true. So if we look at this particular one and we start out with the smallest non-negative integer, which would be 0, well, 0 plus 41 is equal to 41. That's a prime number. If I let n equals 1, 1 squared plus 1 plus 41 is 43. That's a prime number. 2 squared plus 2 plus 41 is 47. That seems to be a prime number. And I keep checking out values, and yeah, it looks like I looked at lots of examples and it's true. I can get up to like 39 squared plus 39 plus 41. 1601, prime number. But when I get to 40, 40 squared plus 40 plus 41 is actually 1,681, which is 41 squared. So it's not a true. This proposition is false because we found the counterexample. Here's one that's false. Remember, true means true all the time. But it took me quite a lot of work to find that counterexample. So not everything that we study will be obvious, and we'll learn techniques to try to determine in general, is it always true or can it be false under some conditions? So in this course, we'll look at several topics, all of which are related to some aspect or some discipline within the computing sciences. Sometimes we'll talk about applications, but often we won't, because the job in this class is to give you the mathematical background in discrete math so that when you go on to computer science courses that use these mathematical techniques, you're already familiar with them. So we'll talk about propositional logic and predicates, which is important from determining if a program is correct. You actually see that when you're software engineering courses. Logic design for computer chips, even writing computer programs. You use this logic to make sure that it does what you think it should do. We'll talk about sets and set theory, which are used to build discrete structures, either mathematically or as data structures. Number theory, which you might could use in cryptology. Functions, which are used to define discrete structures such as sequences and strings in computer languages, and used to measure and compare efficiency of algorithms, which would be an important topic that you'll look at later on in other courses. We'll talk about sequences and sums that are used in both data structures and in counting. Recursive definitions, like recursion in programming, to understand what you're really doing. Relations, such as relational databases. And again, always this topic will come up, well, how do we know this is true? How do we prove something is true given this set of assumptions to begin with? The recommended textbook for this course is Discrete Mathematics and Its Applications by Kenneth Rosen. I suggest that you buy the 6th edition, which may be available at the bookstore, or you might be able to find it online at like Amazon. There's also a 7th edition of this book. The major difference between the 6th and the 7th edition is that the 7th edition is a lot more expensive. All the readings in this course are relative to the 6th edition. So if you have another edition of this textbook, it's fine, but you might have to do a little work to make sure you're reading the correct sections, since the numbering sometimes changes a little bit. Also for this course, for every topic that we cover, there'll be a series of short videos that will be available on Canvas. There'll be a homework assignment that's submitted online, and you need to be careful to look at the due dates for each homework assignment and submit them on time. We do not accept late homework assignments. So once the deadline is passed, you're done with that one. And one of the problems that students have with this course is they forget somehow to submit the homework. That's not a great idea. There will also from time to time be handouts. They're also posted on Canvas, and announcements that are posted on Canvas. If it's on Canvas, you're responsible for it. Your final grade for this course will be based on your homework grades and your grade on the midterm and the final exam. The percent that each of those 3 components count will be posted on Canvas. The final letter grades will be assigned on a 10-point scale. 90 to 100 is an A, 80 to 89 is a B, etc. Please note that all the homework assignments have specific due dates and times, and we do not accept late homework. If the homework is turned in late, it is a 0. Most of the homework assignments are on Canvas weeks before they're due, and you can work at your own pace to stay ahead with them. This semester, the midterm and final exam will be taken in person on Clemson's main campus. On Canvas, we will post the dates, times, and locations for the midterm in the next week from now. Let's talk some about homework, which I think is the most important thing about this course. The purpose of homework is to give you an opportunity to learn the material so that you're prepared to take the midterm and final exam. All the homework assignments are posted and submitted via Canvas, and I automatically grade most of the problems on the homework assignment. Now, the way you should go about this is that you should solve each homework problem on paper before you submit your answer online. Sometimes that the answer I'm asking for might be just a number or true or false, but there's usually a proof or some amount of work to come to the correct answer. Guessing is not a good idea. As an example, suppose the homework problem is asking you, is the propositional logic statement not P and P or Q implies Q a tautology? What that means we'll learn in a later lecture, but the answer that you'll give on the homework assignment will be either yes or no. But the way you come to that answer is you sit down and you write a short proof so that you know that you have given me the right answer. Guessing is not a good idea. Now, every semester, I seem to have a few students who have a personal philosophy of never doing homework. If you do not do homework, then this will be you when you take the midterm exam. You being the water buffalo who's having a very hard time with the lions. The homework is a learning experience. The homework is designed to prepare you for the midterm and final. The homework counts a big part of your final grade. So do the homework. That's where you'll learn the majority of this material. Also, I have something in this class which we call the collaboration policy. Simply stated, it says that collaboration between students on homework assignments in this class is permitted and encouraged. I don't care if you actually do the homework in groups. I don't care if you actually talk to your smart uncle who teaches computer science at another university and ask him to help you with your homework. You can talk to your roommate about your homework who took this course and did well last semester. My assumption, however, is that collaboration involves students working together to understand the course concepts and the course material, and you're actively seeking to learn and understand the topics covered in the course. Once you submit that homework assignment, I expect that you can understand and explain the solution that you turned in, no matter how you came to that understanding, whether on your own or discussing it or arguing about it with other people in the class or your friends who have had this course. Plagiarism is not allowed. So you shouldn't copy assignments that you don't understand from other classmates or find the solution online and just download it when you haven't taken time to understand it. These are simply meant to earn a score. And once you get to midterm and final, I'll figure that out. The majority of your grade will be based on the midterm and final exam. So you need to use the homework to prepare yourself for those two exercises. Miscellaneous, I'll have material posted so you can actually work ahead of the schedule. You don't have to wait to the last minute to submit the homework. You can submit it early. That's actually recommended. If you're a special needs student, you need to email me immediately about your special needs in this course so we can work things out along with the documentation from Student Disability Services. And I'll remind you that Clemson has an academic integrity policy, and I expect every one of you to follow it. This is a good course. It's a very important material for a computer scientist. I think you'll enjoy it. Keep up with the lectures. Email me if you have problems or don't understand something about the course.